Alright, section 5.5, hyperbolas. As usual, we have this problem where we have to take an equation in general form and change it to standard form so that it's easier to graph. So here's kind of our step-by-step instructions. What I feel like is missing from this is that somewhere in here we need to make sure we factor out the negative. From the variables matching the negative squared term, right? The other thing that's not really stated here is that you should put the positive squared term and its variables first, and the negative squared term and its variables second. Factor that out and go from there. Okay. Alright, this one is a little bit of a crazy problem because it's got fractions. Let's do this. We've got it. So we have 9y squared, and then we've got our negative on our x squared, so we're going to factor that out. Factor it out of the 6x. Leave some space. We've already got the 10 on the other side. That's convenient. We're going to complete the square by halving the 6, which is 3, and squaring it, which is 9. So what we add to one side, we have to add to the other side, but we're not really adding a value of 9, we're adding a value of negative 9, so we're going to subtract 9. This gives us 9y squared minus x plus 3 squared. So the number we got when we halved it is the number in our binomial squared, and then 10 minus 9 is 1. So at this point we would divide everything by 1, but that feels really pointless, right? Because that doesn't really do anything. We already have a 1 on the right, so it says divide by the constant. That's just to kind of start getting us the feel of having those fractions in there. We need that 1 here so that we know what a is, because a is going to be 1, right? But b, don't we need a coefficient of 1 right here? So we've got to do some tweaking here. We've got to change our 9y squared to y squared over 1/9. So, you know, when you divide fractions, to simplify that, you take the numerator and you times and you flip the denominator. So this is kind of the reverse of that. We're undividing this fraction in order to get a 1y squared here, which means instead of dividing by 9 or multiplying by 9, we're dividing by 1/9. Kind of weird. That's why we're looking at it in case it happens somewhere else, but I don't think you're typically going to see a problem like this, so don't worry too much. Of course, the examples in the book are always going to be a little bit more difficult than the problems themselves that you're working on. Okay, so then we've got our x plus 3 squared over 1, and that equals 1. So we have b is the square root of 1/9, which is 1/3, and we have a, which is the square root of 1, which is 1, and we have our slope. So our slope would be b over a, so that would be 1/3 over 1, which is just 1/3. We'll work with that a little bit more here in a second to find our asymptotes. Alright, now graphing 1/3 is not going to be easy, so I don't know if we want to count by 3s or count, yeah, so that every 3 squares equals 1. We can do that. The other thing we should do really fast is find C. I don't know if we really need C because it doesn't ask. Oh, it does find this. Find the foci. Okay, so we are finding it, but it's not important to the graph. Let's go ahead and do that though. So C will be a squared plus b squared, so 1 plus 1/9, just the numbers on the bottom. Add, because it's the opposite of that sign. So get a common denominator, 9/9. That gives us 10/9, so that's going to be a little bit more than 1. That can simplify to square root of 10 over 3 if we want, which we're going to use that when we actually write out what the foci, what the coordinates actually are. Alright, let's take what we've got and figure out, write down a few things like center. So the center is at hk, and the h value is with x, and the k value is with y. So we go the opposite of this number here is -3, and this one is just a 0. So I'm going to start by putting that in my graph at -3, 0. Then I have my vertices. This graph is going to be vertical because the y is squared, right? So upward and downward. So it's a vertical hyperbola. And since we know it's vertical, that means we know that our vertices are going to be up and down from that point. So we'll do one there, and those vertices are located at -3, +1/3, and -3, -1/3, because that axis will be vertical. Okay, and then our foci will be here and here. So that would be at -3, and then up square root of 10/3, and -3, negative square root of 10/3. Okay, so we've got all that in. Now we've got our slope is 1/3, so our asymptotes will be y equals +1/3 x, but then we need the y-intercept, and we will have -1/3 x with the y-intercept. So let's go ahead and figure out those y-intercepts. It's not going to be as bad as you might think. So for a slope of 1/3, that means a rise of 1 and a run of 3. So if we start even just at the center, we would be going up 1/3. Well, that hits right at that beautiful spot on our y-axis. If I want my asymptote to go a little further back, let's go down 1 left 3. So I'm going to start drawing this with my line tool right here. So there's one of our asymptotes, and then the other one, again, let's come back here to where 3, rise of 1, run of 3, so something to that effect. So I think I've found my intercepts fairly easily just because the slope is up 1/3. So we've got a positive slope intercept of +1 and a negative slope intercept happens to be at -1. So there's our asymptotes. Okay, so we've got the vertices, the equations of the asymptotes, the foci, the center. We just need to sketch the graph. So the graph just follows the asymptotes. I didn't even draw in the guiding rectangle. Everything's a little bit too small here. But we've got the vertices and the asymptotes, so that's really all we need to be able to draw the graph.